Welcome to the Stormsurf Video Surf Forecast for the week starting Monday, 4th of July. Looking at significant wave heights for the South Pacific Ocean, we see not a whole lot going on. A little bit of a gale here with, about 26-foot seas, well east of New Zealand, basically in the central South Pacific, not really generating any swell of interest. Let's take a look, though, at what's happened over the past week. We're going to start on Thursday evening, and specifically, we're looking to this area just east of New Zealand. A small gale developed, cut off the jet stream. You can actually see the flow here going into and over Antarctic ice, but there was a cutoff area here, a little bit of energy, and it started producing some winds and seas to 37 feet over a small area aimed northeast, and just for an instant in time, watch this, it pretty much fades out. So you have about 35-foot seas and a reading of 37-foot seas, and that was about it. So let's give it a 24-hour window of seas in excess of 30 feet, aimed well to the northeast. Swell is already hitting Tahiti, small energy bound for Hawaii, and yet smaller energy still for the U.S. West Coast. And then another system, this was a kind of a quirky little system, had some decent winds here in the almost 55 knot range for an instant on, this was Saturday evening, and then in later Saturday evening it peaked out instantly at 36-foot seas, and then quickly petered out by Sunday morning. Another small pulse of swells expected, seeing how its location was right here at the peak, we'll put it, right there. About at 25, so small energy certainly for Southern California, and then also for Northern California. It's also possible Hawaii could get a little bit of spray from this too, a little bit of what you call it, south-southeast swell. But given the minuscule fetch size here, probably not a whole lot is to be forecast. Let's go take a look at what else is going on. So we'll start off taking a look, of course, at the southern hemisphere, looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales do form, help direct their track. What we're looking for is a trough, that is a push to the north in the jet stream to sort of carve out a little area of clockwise circulation in the upper atmosphere. That also down at the will manifest itself down at the lower levels of the atmosphere. That helps create that's actually the hallmark of low pressure. Low pressure, of course, generates wind. Winds generate seas. Seas radiate away from the fetch area, create swell, which, of course, creates surf. So we see a little bit of a trough, not much, here south of New Zealand on as of Monday morning. Nothing very strong, the weak winds, and here's this big ridge. This ridge has actually been covering the entire of the southern hemisphere for the better part of a week now. It's starting to relax a little bit under New Zealand. That's a good sign. But see, winds kind of fade off. It doesn't do a whole lot. And then another pulse of wind comes in on, Tuesday night. 120 knot winds, but they're actually kind of pushing southeast. And then yet another pulse here on, let's say, Wednesday night, Thursday, finally 130 knot winds and lifting to the northeast a little bit. That's looking a little bit more favorable in this area here into, Friday or so. But notice then the jet starts ridging south again beyond that. But here we have a pretty good open area. Now notice here winds pushing south. So the assumption is there's actually winds falling through this area, creating a ridge. So it's just this little pocket right here that is of interest. And that continues east, but pretty much falls apart on Saturday. And then another trough looks to be building on Sunday or so into Monday, and that actually looks pretty good if one believes it. Pushing well to the north, 130, almost 140 knot winds. But that's just one small area there. Big ridge east of it, big ridge to the west, and then we're 180 hours out. So that would be long-term the area to look for. Let's go take a look down at the surface and see what winds are supposed to do. So here we go. Remember we saw a little area, 26-foot seas here in the mid-central South Pacific. Clearly a cutoff low. We saw the jet is running down here. You can actually see the path of the jet here, right down around here. So really the main area we would expect decent swell development would be somewhere over here and where that trough is supposed to be in the upper atmosphere. And sure enough, come Monday night, we see 35 knot winds building. That's not enough, but then some 40, almost 45 knot winds on Tuesday, and that system pushes east, sort of fades out, and then a stronger system with 45 knot winds with it purely out of the west. But you know, the great circle paths to California pretty much do this sort of a track right here, so that's not bad. And then the winds start pushing more southwest as we get into Thursday, offering yet more hope, and continuing into almost Friday before it peters out. Now here's another system. Notice these winds here are aimed southeast, not so interesting, but maybe something down here. The ice line is right at about 65 south though, so that is likely covered in ice and cannot generate any swell until it lifts further north into, here we go, Saturday. Now remember, there was that big trough that was starting to develop here, and sure enough, we get a good area, 40 knot winds lifting well to the northeast, and look at this little guy here. So you know, if you believe the model, there's some hope. Now, notice you get 55 knot winds, but all this fetch, again, is aimed southeast into Antarctica. It will do nothing for us, and probably not even anything for Chile at that point. Oh, and that's the end of the model. So that looks kind of good. Looking at this, too, it kind of makes me wonder if not this is going to be another trough that'll push east and into the Pacific beyond 180 hours. But you know what? The models, anything more than about 3 days out, aren't particularly worth watching. It's rough guidance, so I'm not going to believe any of this yet. But it sort of looks like summer or winter in the southern hemisphere is doing okay, and that things are not completely shut down. Let's go take a look at the wave model. So here we are, current wave model. And it's like we talked about before, that small area, 26-foot seas associated with the cutoff low. 26-foot seas, you get maybe a 15-second period swell out of that. And that is just below the threshold to pretty much be well decayed by the time it reaches up into the area of California, and it's east of Hawaii, so nothing there. Don't expect much from that. But as we move into time under New Zealand, come about Wednesday, the first little pulse, again, that's only 26-foot seas. That won't do much. But then you get this patch of 30-foot seas on Wednesday evening into Thursday, building to about 34 feet. You could get some swell from that, certainly, but it's a long ways away. It'll get partially shadowed relative to Tahiti. And probably, you know, rideable surf, not a whole lot. Then there's this other fetch that develops in the deep central Pacific on Sunday time frame, 30-foot seas, not a whole lot more than that. We'll see what really happens. We'll roll this out a little bit further. Yeah, continuing in the 30-foot range. That and pushing to the northeast, that's good for some 16, 17-second period swell, if all plays out as forecast. So maybe some hope. And then, of course, this other system south of Tasmania, we'll see what happens with that. So, in all, nothing like what we've been seeing, where we had storm after storm after storm stacked up. The South Pacific taking a bit of a break. We believe that is MJO related, and we'll get into that right now. Our long-term forecast. MJO, La Nina, El Nino, and the state of both surface and subsurface of the Pacific. So first off, we take a look at surface winds in the Kelvin wave generation area. That is the area roughly from 130 east, say just a bit east of the Philippines, out to about the date line. So this area right here, and just 5 degrees north or south of the equator. We see trades in control of the East Pacific, but then you get over here and trades pretty much die out completely. And for this time of year, what you see anomaly-wise, these winds are about normal for this time of year. A little bit of a westerly tendency in pockets, about to south of Hawaii, but nothing particularly noticeable. Certainly nothing that would suggest a strong bout of the active phase of the MJO or anything else. Of course, if you're looking at sea surface temperatures here, you can see temperatures well below normal, about 3 degrees, 2.5 to 3 degrees north and south of the equator, but we'll get into that more in a second. So what we're looking for is westerly anomalies. That would suggest the active phase of the MJO. So the Kelvin wave generation area, we've seen this chart before. Here is past history moving towards current and then into the future. This is the GFS model up about 850 millibars, which is about 4,400 feet in the air. But that's a pretty good proxy for what's going on down at the surface. So you see we had westerly anomalies, Kelvin wave generation areas right here in the early part of June. That helped support a bunch of storms and swells that we got. Then roughly right around the 17th of June, that faded out, and you see we got a lot of easterly anomalies. The blue are easterly anomalies suggestive of the inactive phase of the MJO. That has put the kibosh on storm production as of right now. But now here we are, current time, we're starting to get a little bit weaker west wind anomaly pattern, and that is forecast for the next week to continue, but nothing super strong or organized. You notice there's also patches of easterly anomalies in here, so basically kind of a neutral pattern. Kind of hard to decipher here what the MJO is doing just looking at winds down at the surface and wind projections. So we can use models to help determine the state of the MJO. The preference is the active phase of the MJO, and probably we would prefer a strong one. The MJO, certainly in winter months in the northern hemisphere, strongly affects the storm track. The active phase makes it much more robust. In the summer months, or in the southern hemisphere in the winter, the MJO does not have nearly as direct an effect, but it does have some effect, and we've seen that as of late with the recent storm cycles. Currently, the statistic model suggests a very, very weak active phase of the MJO. A little bit of negative anomalies here in outgoing long-wave radiation, suggesting more cloud cover than normal in the active phase of the MJO. Inactive phase bottled up here in the Indian Ocean. Looking at the next 2 weeks, the active phase is just supposed to disappear and be anemic. The the dynamic model basically suggests the same thing. Neither a decent active or a strong inactive, just a neutral state for the next 2 weeks. Here's yet another way to look at that. Assume that this circle, you're looking down on the North Pole, moving from the maritime continent over moving counterclockwise over the date line into the West Pacific, over the continental United States, into the Atlantic, over Africa, and then back to the Indian Ocean. The active phase of the MJO moves counterclockwise in that fashion. Right here is where the current state of the active phase is in the West Pacific. If it's inside this circle, it's considered to be very weak. That's consistent with what we saw on the other two models. And the forecast for the next 2 weeks just has the active phase of the MJO weak and incoherent, maybe migrating back into the Indian Ocean. The GEFS, the ensemble GFS model, basically suggests the same thing. No real active or inactive phase suggested. But then we look at another model. The CFS version 2 model, again, 850 millibar winds up about 4,500 feet. Now, this runs, here's past history. We're looking for oranges and yellow, westerly anomalies. Kelvin wave generation area roughly in a line going up here, from here up to about the date line, a little bit east of there. Here was our last bout of westerly anomalies, and we can overlay this associated with the active phase of the MJO. The inactive phase of the MJO is past history now. Supposedly, we're moving into another active phase. We saw this on the other models as well, but a very weak one. Not a whole lot of westerly anomalies expected. Probably not a lot of support for storm development, and that through about let's say the 19th or 20th of July. And that's the good news. After that, the inactive phase of the MJO is forecast to take over these dotted contours here. Easterly anomalies, that would definitely not support storm development. You know, it is not very, it's pretty normal through somewhere in July to about mid-August to not have a whole lot of activity in the southern hemisphere. So this is sort of shaping up like a normal year. And then somewhere about late August, and sure enough, you know, the storm door wakes up again in the southern hemisphere. That's what this model suggests with the active phase, again moving in, not making it very far west, but pretty strong, and holding into, so starting, what is that, about mid-August into about the mid-September or so, and then things kind of falling apart. So this would be probably, you know, if we don't get anything here, and what we're seeing on the near-term charts is, yeah, some storm development, but nothing very strong. But, you know, take whatever swell you can get, make the most of it, and then another pulse probably in August. So pretty much a standard sort of pattern for the summer. Nothing compared to what we've had. We've had 9 significant class storms or swells already this summer, though a bunch of it has all been overlapped, and you get 3 of them at the same time, or basically in a 4-day stretch, rather than having it more spaced out and getting a longer run out of it. But that's okay. It was fun while it lasted. Finally, overlaying the low-pass filter here. This shows you where the center of, we'll call this convection is, better odds for tropical development. And clearly, and this is where you really look for El Nino, and El Nino was in control. And the final contour of any El Nino enhancement is suggested gone by about September 2nd. And notice here it starts redeveloping over the Indian Ocean, which was classic La Nina. So then you get this dotted contour, sort of negative enhancement for storm development over the Pacific as we move into the fall. Pretty normal La Nina kind of pattern. But the question is, how strong will it be? Hard to say. We'll look at some charts, try to make some best guesses, but so far it's not looking particularly robust, which is actually good news for us. So first off, looking at subsurface temperatures. West Pacific here, East Pacific here, actual temperatures, and you sort of see the distribution, and this is a couple of degrees, 2 degrees north and south of the equator. Most of the heat, as expected now, bottled up in the West Pacific. If it was El Nino, it'd be over here, moving back to its normal position. Cooler temperatures in the East Pacific. The 28-degree isotherm line right here, chopping off now at 165. It was holding about 159 west or so, continuing to migrate to the west, just suggesting that La Nina is continuing to build. Anomalies, differences in normal for this time of year. You see your warmer anomalies, but not particularly warm, 1 degree above normal here in the West Pacific. Also a weird little pocket here off of Ecuador, also 1 degree above normal. But the main feature is this pocket of much cooler than normal water. Per this image, it's isolated to just mainly the central equatorial Pacific, 4 degrees below normal, and upwelling somewhere here between about 130 and about 160 west, so south of Hawaii somewhere. This is a little bit higher resolution view here. This view, same sort of layout, suggests the cooler water is making it much further east and continuing to rise towards the surface, towards Ecuador. That would be expected, and this is pretty much classic La Nina. You see this little pocket of warmth here. At some point that will get completely cut off, and this cool water will start upwelling closer to the Ecuadorian coast. Right now that's not happening so much though. Another way to depict what's going on subsurface wise is this from the Jason 2 satellite. So here is Baja, here's Mexico, US West Coast here, South America, Chile down here, Australia. And what we're looking for, the oranges and yellows suggest higher than normal sea heights, not actually sea heights, but ocean surface heights. Strip out all the wind waves, strip out swell, strip out anything, strip out the tides, and compared to normal, what we see here is on the equator in the Kelvin wave generation areas right in here, and right in this area here, is that the ocean is about 10 centimeters lower than normal. That suggests colder water at depth. Colder water, of course, contracts, takes up less volume, and sort of creates a little dip in the ocean surface, not noticeable by anything but satellite and very detailed measurement. Anyway, so this basically confirms what the previous images suggest, that cool water is from Ecuador across the Galapagos, with the main pocket out here south of Hawaii. There's Hawaii right there, and making it about to the date line, which is typical of La Nina. Next, we take a look at the surface, actual ocean surface temperatures from the satellite, and as expected, we see cool water here along the coast of Peru, though not as cool as it's been the past week or so, sort of backing off a little bit. La Nina, it pulses, it might go strong for a week or two, back off for a week or two, sort of like the MJO, but not MJO runs in, let's say, 3 to 4 week cycles. The La Nina and El Nino, for that matter, pulse according to the MJO, but they sometimes have a rhythm of their own, unrelated to that. Anyway, we see cooler than normal waters. What is this about? Well, eyeballing it roughly, let's say 1.75 degrees below normal right there near the Galapagos. And then another pretty good pocket out here south of Hawaii. But in general, see, these are the last remnant pieces of El Nino, and the cool pole is emerging, advecting off to the west, driven by easterly trades and upwelling and subsurface temperature dynamics. The trends, here we see what's been going on for the past 7 days. The blue pockets are where temperatures are colder than normal. The red pockets are where temperatures are warmer than normal. So you can see it there, and you can see it here. There's like these pulses almost running across the Pacific from east to west, driven by trade winds and other sorts of factors. We also look over here off Africa. There was kind of a mirror image. There's little pockets of cool water here, and there was kind of a pulse coming off here, but that's backed off, and then it warmed up even. So anyway, the point being, continuation of La Nina, but this does not look nearly as, it's not trending as cold as it was a week or so ago. Notice cooler temperatures off California, driven by high pressure, I'll call them trade winds out of the north-northwest. Pretty typical of this time of year. Upwelling, you get cooler temperatures. And then also this is, we believe, PDO related, Pacific Decadal Oscillation. Cool, warmer water here, much warmer than normal. And then this builds up off the coast of the Pacific Northwest. And then north of this, cooler temperatures. Here is the broader view. You see the same thing. Here's our cool La Nina pool developing. Here is our PDO warm band, and then you see pockets of a little bit of cooler water north of there. So the short of it, La Nina is happening right now by all this data. Not as strong as it was, but I am sure that it will pulse again. The PDO looking pretty much like it's in the positive phase still. We need to get into next spring before we know whether it's real or not. Next, we talk about atmospheric coupling, the coupling of El Nino or La Nina, that is, water temperatures and what's going on there, to the atmosphere above it. So back January 24th, 14, El Nino started. You can see that this is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. You can see the downward trend in the Southern Oscillation Index. That's classic El Nino. When you get into negative numbers, it's 30-day running numbers down around -22. That's strong El Nino. You can see pulses of the MJO. Here's the active phase there. These downward pulses, that's the active phase there. It's all started with a massive active phase, of course, back in spring of 2014. But now notice the trend appears to be moving markedly upward. This is the highest the Southern Oscillation Index has been in a little over 2 years now. So suggestive, of course, of La Nina. We can zoom in here at the Southern Oscillation Index daily values. Again, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers suggest the active phase of the MJO. Positive numbers, the inactive phase of the MJO. In June here, we're seeing kind of a muddled mixed pattern, though by and large the numbers are positive, suggesting of a building La Nina. The daily value, this is as of June 30th, minus 0.9, which is about neutral. But the 30-day running average, that chart we just saw, clearly moving upward, 3.82. The 90-day running average, which was down somewhere around -18, if I recall correctly, at the peak of El Nino, is on its way up at -4, and ultimately it will go positive at some point, probably in late August or so. And then finally, the ESPI index. This is difference in, rather than pressure, difference in precipitation between the area north of Darwin, Australia, and a large area north of Tahiti. The negative numbers in the index suggest La Nina. Positive numbers suggest El Nino. Current value, minus 0.93. That is suggestive, of course, of a developing La Nina. But for the most part, yeah, it is La Nina. I can't even stretch it and say it's neutral because it's not neutral anymore. During El Nino, it was positive. Oh, I think it got up to about plus 2.125, something like that. We're definitely moving in the opposite direction now. What this and the Southern Oscillation Index suggest is the cool water, that cool water that's developing right here, is starting to have an impact on the atmosphere, starting to change the upper the atmospheric circulation from that bias towards El Nino to at least neutral now, if not moving towards El Nino. But remember the low-pass filter we saw in the CFS model? It suggests that El Nino is still supposed to hang around till, let's say, early September, and then sometime after that will make the transition in the atmosphere. I suspect it will hang on a little bit longer than that, and that we'll still see some push, some evidence of El Nino in the atmosphere, irrespective of what the numbers say, probably until about the early December time frame. So that would suggest a rather early start and maybe a good start to the fall season in terms of swell production, and then things fading out as we get deeper into the winter and turning more La Nina-like. So what that means is, as you get in, El Nino, a lot of storms back to back, a lot of mayhem going on. La Nina is more a storm and then a break and a storm and a break, and if you get a swell, it only lasts a day or two. It doesn't hang around a long time, and the swells tend to be less strong, less period, less duration to them. So you gotta strike while the iron's hot kind of approach to surfing. And then finally, the sea surface temperature forecast for the Nino 3.4 region. This is that region north of Tahiti, the main region for monitoring El Nino and La Nina. As of right now, temperatures per this, the CFS version 2 model says temps are about, maybe a tenth of a degree below normal, basically neutral. And that the forecast is that they are to continue falling to about minus 0.6 in September, and hold there through winter, and then slowly start moving towards neutral. If this is what actually happens, that is a pretty weak La Nina. We'll see if it happens. Other models suggest close to the same thing, down to about minus 0.8. I mean, not even 1 degree deviation. So that would be good if it were to happen. Here's actual surface temperatures in the Nino 3.4 region as of today. Basically dead neutral, and been hovering somewhere around there since June 20th. You can see back in April, we were at plus 1.5, and we were actually much higher than that at the peak of El Nino, somewhere in the January time frame, if I recall. So right now we're hovering around neutral, but we expect temps will get down somewhere in this region before this winter is out. That's definitely La Nina. Half a degree deviation for 3 months. For a couple of those periods running is the definition of La Nina. But the issue is if you're only at minus 0.7 or 0.8, somewhere in there, that's not a super strong La Nina. That would be the best possible outcome for us given the magnitude and strength of the previous El Nino. Pretty typical after a strong El Nino, you get a strong La Nina bounce back. Our El Nino was strong by the numbers, but in how it manifests itself, certainly in California from a rainfall perspective and even somewhat from a surf perspective, it was strong, but it wasn't, certainly didn't compare to 97, 98. We think that is because this El Nino happened while the negative phase of the Pacific Decadal Oscillation was in place. What this El Nino really did, we think, is help push us from the negative phase of the PDO, which is a long-running 15 to 25-year cycle that either favors El Nino or La Nina. And we think this El Nino pushed us out of the negative phase of the PDO, which has been in place since the 97, 98 El Nino. That El Nino was so strong, the rebound from it pushed us into a long-running La Nina via the PDO. And maybe we're turning the corner towards a more positive outlook for the next 15 plus years. So if we got to suffer through a little bit of El Nino this winter, that's not much of a price to pay for maybe a decade or two of better conditions beyond that. Also, we need to look at the tropics. There is a hurricane, Hurricane Blas, Category 1, 65-knot winds here, south-southwest of Cabo San Lucas. Let's take a look at another chart. Here we go, Hurricane Blas right here, 65-knot winds, forecast to build to 105 knots, positioned here. The models suggest some fetch, decent fetch from the south, counterclockwise circulation in hurricanes, low pressure systems in the northern hemisphere. Some fetch is supposed to produce swell, pushing into Southern California, probably, and a little bit into Northern California, but this track is not favorable. Typically, you want a track that pushes more to the north. So we're going to take the models with a grain of salt. Anyway, Blas supposed to work its way, eventually moving over cooler water, fading out. Wednesday looks like the peak of it, 105-knot winds right here. And then a slow fade after that, not making it to Hawaii. It's out to 135 west. Hawaii's off about 150 west. But if anywhere were to get surf from this, most of it would be pushing towards the direction the storm is traveling. So Hawaii has a shot at some swell, some Blas. California, much less. So we have odds for maybe some small surf from a tropical source. Certainly a little small pulse of swell from the gale that's already happened that was just east of New Zealand, and maybe another pulse behind that from the system that was in the southeast Pacific. Looking longer term, the MJO doesn't look particularly favorable. Maybe in the next week or two we might get some more storms. We saw that on the charts. System pushing under New Zealand. Good for, again, small southwest swell relative to Hawaii and California. Beyond that, the MJO looking not very favorable as we go further term. And La Nina building, but not particularly strong, rather weak given the strength of this previous El Nino. The hope is that the PDO moves in our favor once we get through the winter. Yet to be seen. But overall, there is surf expected. It will not be flat, so make the most of it. That's it for this week. Enjoy your 4th of July holiday. We'll see you next week on Sunday as usual. Same time, same channel. Thanks for watching.